Hi guys, and in this video, we're going to look at the checkup that you just completed and you should have got back from your teacher marked. So this is for Unit 3. You should have had this mark back from your teachers, and then again you should have the usual what went well and then an action point. So you should have one of these codes, to go away and onto LMAS and watch and make some notes. So hopefully this video will just free up some lesson time. To make sure that we got enough time to finish the course and give you enough time for revision at the end as well. So let's jump into it. First one we got is radian. So the diagram shows a circle with a center of O and a radius R. The points P and Q on the circle such that POQ, so this angle here, which I'm going to mark on, is 1.12 radians. Given that the area of the shaded region, so this blue area here I'm going to shade in, is equal to 10.35 centimeters squared, find the value of R. So I need to find the radius. Now, what I'm going to do first, I'm going to think about how did I find this area, the shaded area by here. Now, for that, that's a segment. So we're going to think about how we find the area of a segment. So that would have been the whole sector. So this whole slice of my circle, take away the area of this triangle. Now, if this radius is R, this radius is also R. So if I'm thinking about the shaded area, I would have done the whole sector first. Now we know how to find area of a sector. That's a half R squared theta, where theta is in radians. And then I'm going to take away the area of the triangle. Now the area of the triangle will be a half AB sine C. So AB are both R, so that gives me R squared. And then sine C, so sine of theta. I'm just going to plug in my numbers. My shaded area is 10.35. This side here, I'm going to leave it as it is for now. So I got R squared times 1.12 minus a half R squared sine of 1.12. Now obviously we're working in radians, so make sure you calculate in radians before you start using the sine. Now on that right hand side, they've all got an R squared in it. So I take an R squared out and I got a half times 1.12 minus a half sine of 1.12. And I've done that because what I'm going to end up doing, in fact, let me make that 1.12, not 112. I'm going to type what's in that bracket. So if I type in what's in that bracket, R squared times by, and this bracket gives me 0.1099 ... And I'm just going to divide by that on the other side. So that gives me R squared is 94.133. Again, I'm not rounding anything as I go along here. I'm just simply going to square root for my answer. I'm going to get 9. It wants it one decimal place. So I get 9.7 centimeters. So I thought about how I found the area, and I just plugged in my numbers from there, But you need to get this initial step here of thinking, how did I find that shaded area in the first place? So for question 2, we've got some inequality stuff, some trig identities used here. So I've got to find all the values between 0 and 360. So now I'm swapping back into degrees, so make sure we do that to satisfy this equation here. So I've got 13 tan squared equals 5 sec squared plus 6 tan. Now, at the moment, I can't really do anything because I've got some that's got sec squared in it, and I've got some that have got tan squared in it, and I've got a tan. Now, this one here, this 6 tan theta, I can't change. I don't have an identity for that, So that means that one has to stay. Now, because that has to stay, I have to make all the other terms tan. Now, this first one is tan, 13 tan squared theta. This one here after the equals is 5 sec squared. So I need to try and get rid of that. So to get rid of that, I'm going to use the identity. That sec squared is 1 plus tan squared. And just sub that in. So if I sub that in, I get 13 tan squared theta, can't change that, is 5, and then brackets 1 plus tan squared plus 6 tan theta. I'm going to expand out that bracket and I'm going to simplify as much as I can. So we can kind of see I've got a quadratic form in here. I've got a term with a squared in it. I've got just the tan, and I've also got a constant as well. So from here, I'm going to take everything onto one side. Now, I want to keep my tan squared positive, so I'm going to take everything over to the left. So I'll put equals over here. So I've got 13 tan squared. I'm going to take away 5 tan squared, gives me 8 tan squared. Plus 6 can become minus 6 tan over here. And then plus 5 can become minus 5 over here. Now, I've just got a normal thing that I need to factorize at this point. You would have done loads of these last year. Okay, so it works out in the same kind of way. The first bracket would be for tan theta minus 5. Second one would be 2 tan theta plus 1. Okay, so again, what lots of you have probably done is you found the answers using your calculator. So obviously this gives me 5 over 4, and this one gives me minus 1 over 2. But you need to make sure, if you are doing that you get back to this line for a mark. Okay, so work your way backwards. Right, from there, I'm going to find my values for theta. So for the first one, okay, if I do inverse tan, my first value that comes out is 51.3 degrees. Okay, now obviously we need to find it in a range, so I'm going to draw just a quick sketch of my tan graph. So my tan graph should do something like this. Okay, and I'm going to find out my other key points. So 51.3 would be about here. So you'd find a corresponding value over here. So I'm going to add it on to 180. That's going to give me 231.3 degrees. Okay, then I'm going to do the same for this one. Okay, theta. And the inverse tan. Now, in this term, it gives me a minus 26.6 degrees. Okay, which obviously would be down here. Now, that isn't in my range, but it helps me find the other values. Because this one's about here. I need to find out these two. Okay, so I need to do 180 take away 26.6 and 360 take away 26.6. Okay, are going to give me the two values of 153.4, and it's also going to give me 333.4. Okay, so the final thing I'm going to do, I'm going to therefore, and I'll write them all out, because obviously I don't want this one. Okay, now when I write them out, I am going to put them in numerical order. Okay, it just helps out a little bit with the examiner in terms of finding your answers. Okay, so if you put them in order, it does really help. And there we have it. Okay, I've got my 4 answers there from my graph. Obviously, I haven't included a negative one because it's not in the range that I'm looking for. So for question 3, we've got the modulus function. Okay, so I want to find the range of values for which satisfies this inequality here. So we'll solve that. So let's do that bit first. So I've got 1 minus 3x. I want the modulus of that is greater than 7. Okay, so what we need to make sure we do is I do the first one where I just leave it alone. I get rid of the modulus. Or, okay, I'm going to do 1 minus 3x. Now I am going to flip the 7 to a minus 7, but that means I also need to flip the inequality. Now I'm going to solve these two separately, okay? So in this terms, okay, I need to take this minus 3x over to the other side, so it becomes a positive 3x. At the same time, I'm going to take the 7 over to the other side, so I'm going to take away 7, so I get minus 6. And then I'm going to have an x and minus 2. So x must be less than minus 2 is my first one. I'm going to solve this equation as well in the same manner. I'm going to leave my inequality in a minute. I'm going to take 3x over to this side. I'm going to add 7 onto the other side. That gives me 8. So that gives me 8 over 3. Okay, now normally we have to decide, am I going to put these two things together or am I going to leave them as separate? So you can think of it as a number line. If I want it less than minus 2 or greater than this, I can't really put those together. It's not in between the two values I've got. It's outside. So I'm going to have to write, therefore, x is less than minus 2 or x is greater than 8 over 3. And there's my two answers. Right, now for part B, I'm going to draw a sketch. Okay, now if you notice, I've got to do y equals the modulus of 1 minus 3x minus 7. So I'm going to use the kind of key points from before, okay, but I just clearly label the minimum points and where it crosses the x-axis. Now, where it's going to cross the x-axis are the two values I found in part A. Okay, that's where it's going to cross my x-axis. If I draw my axis out, okay, it's going to cross it at minus 2, which would be about here. Now, obviously, we should just use a ruler and pencil to quickly draw our axis. It's going to cross at 8 over 3. Now, I need to find where the minimum point is. Okay, so if I look at the equation I've got, Now, this modulus, the smallest this modulus can be, okay, is 0. Okay, now when that does equal 0, y would be -7. So the minimum is going to be at -7 somewhere down here. Okay, but I got to figure out the corresponding x value. So if I do set that to make equal 0, -3x equals 0, and I solve that, I get x is a third. So it's going to be about a third, which would be about here. It's going to go down to there. So that would be a third and -7. Okay, now apart from that, we are going to have our normal kind of V shape that we're used to having. Okay, now I haven't obviously perfectly gone through 2, so I am just going to quickly relabel it. Okay, but I'm obviously not using a ruler, whereas you should. Okay, and there is my my graph drawn for this function. Okay, so if you find the inequalities, I basically looked at it when it's equal to 0. Okay, if we didn't have it, that's all I would do. Like, okay, when y is 0, what could this equal? And I'd solve it for my two values. And I've got to think about the minimum. The minimum is always when the modulus equals 0, because otherwise it can't be a negative, because as soon as I take a modulus, it's going to become a positive, and so on. Okay. So the final question, okay, we've got, it tells me theta is small, okay, so I need to use my small angle approximations, show that the expression of this, it can be written as 9 theta plus 2, so there's quite a lot of simplifying here to do, okay. Now I've got quite a nasty fraction here, so what I'm going to do is I'm going to split it up. I'm going to firstly look at the numerator and see how much I can do with this before I go any further. Okay, so let's use my small angle approximate. So cos, okay, is going to be 1 minus, and then theta squared, which in this case is 3 theta. So 3 theta squared all over 2. Okay, minus 2, can't really do anything with that. Plus sine theta becomes just theta, so I get 5 theta in this case. Okay, and I'm going to basically expand and solve this as much as I can. Okay, so I'm going to expand everything by 4, so I get 4. Then I get, I'm going to get 9. I'm going to get 9 on the top, divide by 2, and then I'm also going to time by 4. Okay, that's going to give me 18, so minus 18 theta squared, minus 2 plus 5 theta, and then I've got minus 18 theta squared, and I'm going to get plus 5 theta plus 2. Now I need to factorize this, okay? I've got a quadratic. If I want to simplify things, I'd have factorized as much as possible, okay? So if I do factorize this, you notice that the first one is a minus, which means one has to be a positive, one has to be a minus. So I'm going to have if we do factorize it, we end with minus 2 theta plus 1, and then we get 9 theta plus 2. Okay, now you kind of see that term there matches up with this term over here, okay? Now, if I now look at the denominator, my denominator is 1 minus sine 2 theta. So if I use this, okay, and I use my rules again, that would become 1 minus 2 theta. Use my small angle approximate. So if I put these two things back together, okay, so if I go to, so my fraction will become minus 2 theta plus 1, 9 theta plus 2, all over 1 minus 2 theta. Now, it may not stand out to you, but actually, this term, this first term on the numerator on the top, is the same as the denominator, it's just written the other way around, okay, which gives me 9 theta plus 2, as required. Okay, now what you need to not fall into the trap of, and what some of you might have done, okay, is when we're trying to factorize this quadratic here, is not go into your calculator, okay, because what will happen is you'll get two different values out and you'll forget the fact that one of them needs to be a negative to make minus 18 theta squared, okay? So apart from that, make sure you've done any fractions you need to. Now again, you should have an action point, which is your TR maths video. So make sure you now go and do your dirt on that. But apart from that, I will see you in the Unit 4 video. Thank you guys.